We started out by doing 250 hours of clinical rotations throughout the member institutions here at the TMC. And then we kind of vetted and validated needs that we saw from an outsider's perspective during that process with some of the different stakeholders here in the medical center, and narrowed it down to one need, which we've decided to work on. And it's been really great because the clinicians have felt like they've been kind of a part of the process since the very beginning, because they were there when we identified that need. And so we've been able to have constant interactions with them throughout the design process, which has helped us come up with a great product that we have today, which is Intuitab Medical. And at Intuitab Medical, we've designed a device that eliminates the guesswork from spinal taps. So, do you want me to talk about the procedure?
Yeah.
Okay. A spinal tap is a really challenging procedure in which a physician has to advance a needle between two vertebrae through a dime-sized opening. And they have to feel for the vertebrae using their hands. That can be between multiple layers of soft tissue and fat. And so it can be really, really challenging. And the technique's very, very archaic and old, and it actually fails 70% of the time, requiring multiple attempts in order to properly place that needle. This is extremely painful to the patient and can be extremely frustrating to the physician. These procedures can take anywhere between 30 minutes and 2 hours, depending on the difficulty of the case. And so oftentimes these cases can be deprioritized, causing a delay of treatment and significantly impacting the emergency room throughput, causing an ER bottleneck. So we've designed a device that helps physicians detect those underlying vertebrae. We have an array of sensors that clips onto the front of our device, and when pressed up against the patient's back, it can detect the vertebrae, even through multiple layers of tissue. We also incorporate a needle guide in order to help the physicians consistently advance the needle into the proper place. And we have digital pressure sensing and fluid collection system in order to help with those steps of the process as well.
And that's something that's in use now across?
So it's in the prototyping stage. So we're testing this device now. We've done benchtop testing, and then we just got approved to do an IRB here at Rice University. So we'll be testing our imaging platform on humans within the next week, which is really exciting. But yes, so the value essentially that our device brings is we hope to standardize this procedure to be 30 minutes or less, meaning that there's less attempts required in order to place that needle, so less frustration to the physician, more importantly, less pain to the patient. And because we can increase emergency room throughput by standardizing this procedure, we can save hospitals an average of $600 per case.
That's great. Tell me, how did you end up in this great space here?
So applied through biodesign for the biodesign program, just like the other fellows here. I think there were over 500 applicants, and 8 of us were selected from that pool. We were separated onto 2 teams of 4. We were separated into 2 teams of 4. We've got 3 engineers on our team, and then a clinician with an MBA as well. So we've got a solid team covering all the bases.
Is there a lot of interaction between all the groups in the whole building?
Yeah, it's really great being here because we have access to companies here in X+, which are a little bit more established, but then also the startup companies that come through TMC-X, who are a little bit more early stage. So we get to partake in some of the classes that they get to go to, and it's really helped us develop our business plan and develop our device. And not to mention all the events that are here. They have a lot of people coming through who are important in the med center and who've been really, really helpful to getting our product to where it is today.